Alrighty, the mic wasn't on while we recorded this, so I'm just going to say go and look at the flowchart review PowerPoint in our notes section. And we don't need this page. Well, we could talk about this page very briefly. The same idea for a method in this language as there are for functions in other languages. When you invoke a method, it just runs off, performs some other code, and then returns. That's what that's indicating. But we don't really need that slide. Let's make it go away, and then we'll post this to our news and to our content section. So we talked about the math class. And I believe we talked about the string methods. Let me make absolutely sure. So our notes say that we did the Indexof algorithm, or at least the Indexof code. We could express it as an algorithm, it just wouldn't have as much Java syntax in it. We did Indexof and last Indexof string functions. It just searches the string, and if it finds that letter or an entire string, because you can pass it something that's more than one letter long, we could actually look for the word state, and it'll tell you the index number where that character or string begins, or else it'll return a -1. Here's an example of using Indexof to count the number of E's, or at least to print them all out in a string. And the way we do that is we use Indexof, but the second the second argument we pass in is a position. Start looking for an E at such and such position. Now, if you don't specify position, it starts it at the beginning of the string, which is position 0. So the first time through this loop, since we're searching for an E, index of E is going to return what? Well, that's position 0. So what's index E equal? 1, 2, 3. So it's equal to 3. So it'll say found at, and then it would print out a 3. And then our last position would be set to 3, and we would repeat. Now we would look for index of starting at position 3 plus 1, which is 4. So 0, 1, 2, 3, 4. It would start searching the rest of the string. Starting at that position, it would find the next D. Well, if that's at 4, that's 5, 6, 7, 8, and 9. So it did find another one. It didn't return a -1. So it would print found it at 9. It would set the last position equal to 9. It'd come back up here and it'd start its search again at 9 plus 1, which is 10. So it would start looking there, and so on. Eventually, it's not going to find any E's, in which case index of returns a -1, and it bails. Some math functions, math.pow, 10 to the power of 3. Math.abs just returns the absolute value. Math.min, whichever one of these is a smaller value, will get returned. 1 divided by 5 is smaller than 1 divided by 3. Or max. Max returns the larger of the two arguments passed in, so that would return a 2 because we're passing in 1 or 2. Then we talked about add exact, which I'm not going to ask about on an exam, but add exact returns an exception if you try to add, if the result is too large to fit into the data type. Whereas just using the plus sign does not return an exception. It just happily adds it and then it wraps the data around. So if you add 1 and your value is set to the maximum that an int can hold, it's going to swing around and suddenly become a negative number. Whereas if you did it this way, it would generate an exception instead. And we haven't talked about exception handling, but in exception handling, you use what's known as a try-catch. You try something, and if that generates an exception, you can catch it rather than letting it kill your program. For example, and I'm just mentioning this now so that when we hit it again, it'll trigger in your head. Exception handling is how you make your programs bulletproof. And what do I mean by that? If the user enters bad data, you want to be able to catch it. And we've already talked about, some ways of doing that. Like, you could check to make sure that they entered a valid value or something like that. But what if they enter complete garbage? That would generate an exception. Or what if you're trying to write to a file, but the disk drive is locked and you can't write to it? There's lots of things that can cause an error state for the program. One of the easiest is divide by 0. If you have I is equal to 0, and then you print out, so you say int z is equal to, well, let's do int z. Z is equal to I divided by x, print system.out.println z. This will probably generate an error. It's not a syntax error, because the compiler doesn't know that these are zeros, that something bad is going to happen. It's trusting that you're going to give it good data. So we run it. We should see some reg text pop up down here. Here we go. Here's the exception that is generated. java.lang.arithmetic exception. Divide by 0. And our program stopped running. And in a good program, you don't want your program to stop running just because it ran into an error state. If you're writing software that controls, a jet, you don't want the computer to shut down just because it encountered an unexpected state. So you can use exception handling. What you do is you enclose the code that you're not sure if it's going to work or not in a try statement. You're saying, hey, give this a try. And then you use a catch statement. And if an error occurs, you handle it. In this case, probably the only error that would occur when you're dividing is a divide by 0. You can query the error much more specifically than what I did here. You can use a method on the exception class in order to get the error message out so that you'll get this divide by 0 bit right there. Or you can compare it, to find out which exception it is. But we're just going to assume that we know what the error is. Error, did you divide by 0? You naughty, naughty lad. Alrighty. And then it's going to print z, but unfortunately z may not have been initialized. So we should probably initialize z equal to 0. And what do I mean by that? Well, if this division failed to occur, then z wouldn't contain any value whatsoever. So when we tried to print it out down here, there'd be a problem. So we went ahead and we gave it an initial value, and it'll get reset to something if that division works. But if it doesn't, at least we have something to print out. And so I run it, and it says, error, did you divide by 0? So it did not kill the program when we tried to divide by 0. We handled it gracefully. Ideally, we would ask the user again for the input, or we would decide that this is, a invalid series of datas, and we would ignore it and go, did I really use the word datas? Anyways, and we would ignore it and continue on our merry way. So that's exception handling. When you hear that word, just remember it's handling an unexpected state of the program. There's more than one kind of error. There are syntax errors. There are, and gosh, I forget the cute name, runtime errors. And then there are, oh, why is my brain freezing? There's a term that means logical, and I'm not coming up with it. Logical errors. And a logical error is one where you've written the program and it doesn't generate any errors, it doesn't blow up on you, but it gives you the wrong answer. Like if you're trying to see if something is freezing and you check to see if it's greater than 32 rather than less than 32, it might say that it's not freezing, even if it was. That would be a logical error. If you mistype that check and it can't even compile, that's a syntax error. A runtime error is one that where the program compiles and where it runs, but it can get into a state that it can't handle. That would interrupt the program. And this is an example of that. So you can handle the runtime errors. You use exception handling for, if you're talking to a server and then the internet goes down and you can't, access the server anymore. Or if you're opening a file and it can't create that file name because they typed a bad character in the file name, or that you're trying to open a file to read it and that file doesn't exist, or you're trying to write to it and the disk is full. All of those kind of things would be runtime errors. All righty. And then we talked about round, whether you want to round something up or down. The square root function, so these are all pretty self-explanatory. Floor and ceiling, floor will round a number down if it's not a whole number. Ceiling will round a number up if it's not a whole number. Then there are the wrapper classes. The wrapper classes have similar names to the primitive data types, except they start with an uppercase letter. And by convention, that's how you differentiate between classes and primitive data types to begin with. If it has a lowercase letter, it's a primitive value, which is not a member of a class. It doesn't have any methods. But if it has an uppercase letter, then it's a class type. It's a reference type, which means that it may have methods. And indeed, the wrapper classes do have methods. So double is a wrapper class that can handle a double type value, a floating point value that's the same size as a primitive double. But it's got lots of functions involved. One of the most commonly used is toString. No, to parse double. You have a string and you want to parse it to figure out what its value is. This is another thing that can generate an exception. So here we're going to declare a string and we're going to give it some bad data. 3.z. We're curious what that number contains. So we're going to say d is equal to double dot parse double. We're going to pass that string in, and then we're going to print out the value of d. And to make this program more interesting, I ought to be using scanners, to let our user type this stuff in, but we get the idea. So I run it, and it goes kablooey. Here's the error, number format exception, inside of the parse double call, because 3.z is not a valid number in our numbering system. Again, you could put that in a try catch so that it would not generate an error. So you would put try above it, you would put catch below it. Now I'm going to be a little bit more specific than I was up here. I'm not going to put the word exception here. Instead, I'm going to put the very specific exception. So I'm just going to copy it from this error down here. And so if we catch a number format exception, we will print a message. System.out.println could not convert that number. Or bad input, or something like that. That was supposed to be an E, not a 3. Okay. So when I run it again, it's not going to kill the program. It's just going to print a little error message. Could not convert that number. And so D is still equal to 0 at that point. Ideally, you might put that in a while loop. Make them type in a good value. But I'm not going to spend time writing that right now. But this is an example of using the wrapper class. And really there's two uses for the wrapper classes that are the most common. One is just so that you can use the parse function, integer.parseInt, double.parseDouble, that kind of thing. And another is because there are some data structures that will not accept primitive data types, that you cannot stick an int or a long or a float or a double into it. But you can stick the wrapper class versions of it. You can stick a double with a capital D, or you can stick an integer with a capital I. So for those functions, which you will use more in the advanced Java class than you will in this one, you have to use the wrapper classes to get them to even work. So you could do a lot of work with the scanner class. It's got methods to check to see if there's any input waiting, but really I don't encourage you to put that much work into it unless you just really, really know that there's... Anyways, as long as we know next int, next float, next double, and the difference between .next and .next line, then I'm pretty happy. There's our little... Oh, one more that I'm pretty sure we've mentioned in the past, but I will mention again. If we want to find out the largest value that a double can hold, for example, or a long can hold, system.out.println long with a capital L dot max value. That would tell us the largest value a long can hold. Why would you use that? Well, I don't know. It certainly is useful. Well, if you had a float, for example, if you had a float or a double and you wanted to see whether it could fit in a long, then you could compare it against long.max value to see if it was too large to fit into a long. Same with int. So say we have a number like this, double dd is equal to, and let's pick a really long number, 33 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to end it with an L. There we go. And I want to see if that will fit into an integer. So I could do this. If dd is greater than integer dot maxint, max value, then we would print too large to fit into an int. I need to correct that to max. You're right. So print line dd plus space is too large to fit into an int. And it does tell us 3.3 to the power of e to the power of 10 is too large to fit into an int. The substring method. The substring method is a part of the class, of the string class, that you can use to extract a piece of the string. Like say you only care about the first 10 characters of the string. Say you only care about the first character or the first 2 characters of the string. You can use the substring class in order to get that out. And so that looks like this. Say we had a string and it equaled the word Bob, Bobby Brown. And then we want to get just the first 2 characters out of that. Okay, string name is equal to Bobby Brown. We want the first 2 characters. So string F2 standing for first 2. What I would do is this. F2 is equal to name.substring, and I give the starting position, and I give 1 past the ending position. Now that sounds weird, 1 past the ending position. But if you just take the difference between these 2 numbers, you get the length that you're trying to get. I want 2 characters, so 0 and 2. Why do I say it's 1 past the ending? Because we want to go up to but not including index value 2. And if we count them over, you'll see why. That's index value 0, that's index value 1, and that's index value 2. So we want to go up to but not including index value 2. But it's easier just to think, oh, I'm going to take the difference of those. That would make that equal to the first two characters. We could get another one. I don't know what this is going to be, but name.substring starting at position 5 and going to out but not including position 8. How many characters long will that be? Yeah, that one will be 3. So it would start at position 5. 0, 1, 2, 3, 4, 5. So it's going to start at the space, and then it's going to go up to but not including 8. 5, 6, 7. So it's 3 characters long, starting with a space, and then the letters B and R. And what do you use stuff like that for? Well, what if you had a string that looked like this? Image is equal to, I'm going to use single quotes, even though it's not correct. http://somewhere.jpg. This is really not a good example, but it will demonstrate. Like that. That may be hard to read, but that's a double string. And I used a single quote here, and I used a single quote here. So what you could do is, what if you only care about this? What if you found out that that's an image tag, image hypertext tag, and you want to find out what image it's referencing? Well, you could find out the position of the first quote and go one past it. You could find out the position of the last quote, and then you could use Substring to extract that so that your program could actually open that file and display it. So let's do that. Let's make an index counter called I1, which is going to be the first quote, or Q1 for first quote. And it's equal to ss.indexof, and we're looking for a single quote. So although this looks weird, I put in a double quote followed by a single quote followed by a double quote again. Looks like an emoticon. I'm not sure exactly what. A tree sloth with claws. I don't know. Then let's look for the last quote. So we're going to use last index of. Q2 is equal to ss dot, and this isn't the best way of doing it. We should do index of again and specify a new starting position that's one past Q1. Let's do that. That's better. So we're going to do Q2 is equal to index of, and again we're looking for a quote, so I'm using a single quote between double quote strings, but I want to start at position Q1 plus 1. One past the last quote I found. Now I have enough information to get that substring. So the path to my image is equal to ss.substring starting at Q1 but going one past it, because we don't want to include the quote in it, and going up to but not including position Q2. And let's print our image out. System.out.println. Alright, if we're lucky, that'll say http somewhere.jpg. Alright, I goofed. That's because I have the syntax reversed. The quote should go before the angle brace in my string. Like that. All right. So that worked. We were able to parse this data extracting just the relevant data by using substring. We found a starting position, we found an ending position, and we used substring to get the good stuff, which in this case was the file name. I know that this is hard to type, and I'm sorry. There's too many quotes and single quotes. And
There you go. That's learning to listen.
Sure thing. We all good? Good deal. Here's a thought problem for you. Say we have a file name. I'm going to scroll down here and add some new stuff. String file name is equal to system.ini. Write some code that will store only the file extension, everything after the period. Into a string named extension. And as a helpful hint, for the second number of substring, you could just use the length of the string. So if you declare a starting value, I don't know, begin, and then you declare an end value for the end of your substring, just use file name dot length as your end position. That'll save you some time. Okay, so you're going to need something here that'll, well, below that, you're going to need something that will calculate what begin is, calculate the beginning position. Then you will need to use filename.substring to get the extension out and store in a variable, a string variable named extension. All right, so I'm going to shut up just for a minute.
Just noticed the image example that you had up there. The string that comes out has the escape character in it twice.
Right.
Now, if that were actually a variable that brought that back, I know this time we just typed it in, so it does that, but if that were actually something that you went and retrieved, had it in a variable, would it still treat it the same way?
Probably. That's a very good question. We should use the scanner to read that in and let the user type in a slash and see if it treats it / as a single slash or not. I'll do that while y'all work on this part. Don't type in what I'm typing up here. So Skip, look at that. When I typed it in, it didn't convert it to an escape character. It was actually 2 slashes. So that's good to know.
Yeah, I was kind of wondering how you get around that if it didn't.
Yeah. Alrighty, anybody have any success at this? Good deal. I want to see how you did. If you didn't, it's okay.
This is what we do at work all the time, so.
Okay, that's right. Find the beginning of it, add one to it.
Yeah.
Get that substring.
Yeah.
And honestly, it'll work if you take out the comma and the end.
I wasn't sure about that,
There's
so.
well, I didn't tell y'all that.
Yeah. Cool.
But right, see if we can get rid of that end.
Yeah. So that was after the end. Okay, problem. Yeah, cool. Because it goes till the end.
And we put more than just a quote there. So that's right. It'll work now. So now you're looking at this part. And you got it. I'm sure. Okay. I'll demonstrate it up there. So what we're going to do is we need to find the position of the period, because that's, after that is where we will get the file name extension. So how do you find something in a string? We've already done it a couple times up here. We're going to use Indexof, just like you were saying. So int begin is equal to, and our variable is called file name. So file name dot index of, and we're looking for a period. Now that really looks like an emoticon. Okay.
I think I've seen people use that one.
Yeah. Alrighty. Now we have a beginning position and an end position. So let's get that string. We're going to declare a variable called extension. And I could put all of this on one line. I'm going to just put it into extension is equal to filename.substring, starting where we found the period, but really we want to start one past it because we don't want the period in our output. And we want to go up to, but not including the very end of the string. There we go. Now we can print that out. That should have been end rather than length. Sorry, my mistake. Okay, so it did figure out that the extension of my file name here, system.ini, was ini. I'm going to fix something up here that I added. I was doing an experiment. I'm going to undo that. Okay. Now, truth be told, you don't have to use this end. If you're using substring and you only specify one value, it starts at that value, but it just runs to the end. So we can delete that part. We don't really need an end counter. We can just delete that, come back up here. We don't need that at all. And there we go. We've simplified a little bit of code. So if you see substring and it's only got one argument rather than two, the first argument is the beginning position, and since no ending position is specified, it just goes to the end of the string.
Yeah, that makes sense.
we're practically done with this chapter. Doesn't look like it. The slider's not very far down, but we are. So that's the substring method, and index of we know how to use already. You could either pass it a single character or you can look for an entire string. So if I wanted to find where I occurred in that string, I could use index of again. I don't know. Begin is equal to, I'm not going to do anything with it, but file name dot index of, and tell me where dot I begins. We will use it. Alright, so my mind is blanking. If you have a file name, it's composed of two parts. There's the thing before the period, and then there's the thing after the period, which is known as extension. What would the thing before the period be called?
File name?
Yeah,
Call path.
well, I don't like path because that kind of implies more the directory structure. Anyways, I'm just going to call it fn. So fn, in this case, is equal to file name dot index of, starting at position 0 and going up to but not including where we found that dot .ini. I've got a problem here. I've already used fn. Oh yeah, this should be called int. No. This should be dot substring, excuse me. So by specifying value 0, we're starting at the beginning of the string and we're going to go all the way up to but not including the period. And realistically, all we had to do is search for the period, not rather than the whole string, but I just wanted to demonstrate you can search for the whole string. I've got to print it out. Base file name. That's bugging me now. System.out.println. Yeah, I'm going to call it base equals plus fn. So on 2 lines of output, we should see the file extension, which is ini, and we should see the base file name, which is system. If we didn't find a period to begin with, we should generate an error because the file did not have an extension. So if we were going to write this code a little bit more clearly, we would include all of this inside an if. We would go back up here to where after we get the beginning point, we would say if begin is less than 0 or equal to -1. That means it didn't find it. So print out an error message. File name has no extension. And then put all the rest of this in an else. Like that. And why do you do that? Because guess what? It'll generate an exception if you give it invalid values. There is no position -1 in a string, so if you use substring -1, it'll blow up. If you specify a character greater than the end of the string, I also think it will blow up. I'm going to prove that to myself just by compiling this and putting in 100 there. Don't add that. This is just an experiment on my part. And yeah, it gave me an error. So by specifying an invalid ending point past the end of the string, that also generated an exception. So this is acceptable code for pulling the extension out. Except we really don't need to search for .ini. What if the file name didn't have .ini? We already know where the period is, so I'm just going to comment that line out because we already found that value up here. So down here I'm commenting it out. Sorry, I know it's harder to read now that it doesn't all fit on one page. are we good, or do we need more typey time? Last index of is just a reverse of first, of index of. It starts searching at the end rather than the beginning. Formatted output. We've played with this a little bit. Now we're going to actually see a slide on it. You can use printf, which stands for formatted print. And the way it works is you will embed placeholders in your string. And all the placeholders start with a % sign. In this case, it doesn't mean modulus. It's just the start of a placeholder. And then it's got a format specifier. And the format specifier is everything after the % sign up to but not including the first letter. Or up to and including the first letter it finds. So there are several different format specifiers. F stands for floating point. So you use that for doubles and floats. D stands for integer. So you use that for longs, ints, bytes, and S stands for string. So going back to our code, let's use a couple of formatted prints. System.out.printf. Let's print the value of math.pi to 4 decimal. Well, let's just not even limit it. %f. Comma, math.pi. All right, now let's say that we want math.pi, but we only want to see 3 decimal places. So between the % sign and the letter that indicates the data type, we're going to put 0.3. That means 3 decimal places. Now what if we wanted this output to fill, oh, and by the way, I should be putting /ins. Printf, unlike printline, doesn't go to a new line every time. We'll have to go back and add /ins. So say we wanted to fill up 20 spaces, 20 columns on our terminal screen. We would do %20. That means format this output with extra spaces in order to fill 20 characters. And we still want to limit it to 3 decimal places. And now I am going to put a /n. Now I know from experience that if you do that, it pads out the beginning of it with spaces. So it is right justified output. But if I put a minus sign in there, it'll left justify the output. And I know that when I'm waving my arms around here, this is not your left, but okay, anyways. So I'm just going to copy this line, paste it, and add the hyphen, which indicates that this is left justified. Then I'm going to run it and hope I don't get any errors. Okay, since I forgot /n on the others, I need to go back in and add it. Do I need that space before the /n? No, but I think it makes it easier to read the code. So not that I'm sure, but I wonder if we can figure out what the default number of decimal places are. Just as a curiosity, I'm going to multiply this by 1,000 before I print it out. Okay, 6 decimal places is the default if you do not specify a different number of decimal places. I'm going to remove that times 1,000 now. So if we look at our output and compare it to our print statements, we'll see the first one just printed the number as simple as possible, and it did round it down to only having 6 decimal places. 6 digits, yeah. This one, since I said .3, it put 3 numbers after the decimal place. This one, since I said 20.3, padded it out with enough spaces so that it equaled 20 characters as a whole. And we could count them out. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, and 20. So that's 20. Why would you use that? Well, if you want to print columns of numbers. We tried generating columns with the /t, I believe, but it's more reliable to actually specify the width. So let's make a little loop for int I is equal to 1, I is less than or equal to 10, I plus plus, and we're going to print out a little table of values. System.out.printf percent 2d. We're using d now rather than f because we're printing integers. I know that d should mean double, but it doesn't. It means decimal, not sure. Digit. Okay. So I want 2 columns wide for that. And then I want 10 columns wide for my next number, which is going to be I times I. And then 10 more columns for the third argument. I didn't put these in strings. I have to go back and add strings, quotes around it. All right, so I'm going to print out I times I, and then I times I times I. So it'll be a table of squares and cubes. Now I've made some hideous error, probably because I've already defined I previously. Yeah, it says I has already been defined, so I'm going to take that word int out. If it doesn't give you that error, great. So there's our output, all spiffy and lined up. This one occupies 2 characters. I chose 2 because I knew that we would only go up to 10. This one occupies 10 characters. Do we really need that many? Not really, but it puts a nice amount of space between them. And the same for that. If we put minus signs after the percent, if we put hyphens there, it would left justify our output. Now that looks a lot nastier in my opinion, but there's times when you might want it left justified rather than right. Names, strings, words look good left justified, but numbers I think we kind of like seeing right justified, at least in my opinion. So I'm going to take those hyphens out. But I wish this one was named Problem 5B rather than Homework 5B. I'm going to re-upload it with the correct file name. All right, there's 2 sections to this homework problem. There's 5A, which focuses on using printf, and then there's 5B, which focuses on using Indexof and Substring. Let's look at 5A first. Each one of these, all it has in it is a Java file. And you'll have to take this Java file, put it into your own code, and fix it to make it work. So you probably have to change the name of the class to match whatever you're going to make your class look like. This is down in the pending. Let me move it to the do section. I still haven't made a correct unit 2 do. You know what I'm just going to do? I'm going to take that unit 1 out of the description entirely. That's good enough. Same for the in class. Okay. So, homework 5. Is it out of order? Why am I not spotting it? Yeah, it's out of order. And it's got a bad name according to our new file convention. Some of this stuff is like 8 years old. I'm sorry that it's cleaning it up as we go along. So this is 5A and 5B. Has a better name now. And now it's actually in the do folder, so you can find it more easily. And as I was saying, there are 2 zip files. Each one has a Java file with a problem description. Here's the problem description for the first one. Given a value of the concentration of hydrogen ions in a solution between 0 and 1, if it's 0, there's no hydrogen ions in that water. If it's 1, that thing is entirely made of hydrogen ions. The pH, the acidity of that solution, can be determined by using the log10 function. We're using logarithms now, and we don't really have to understand this math. We just need to make it work. So the formula for converting, I did restart this, did I not? Yes. The formula for converting a concentration of hydrogen ions in solution is pH is equal to 0 minus math.log10 of the concentration. So write a program that will look like this. We want to print out the concentration of the hydrogen ions followed by the pH. And just as trivia, water is considered neutral, and it has, by and large, a pH of 7. And everything below a pH of 7 is considered an acid. And the smaller that number gets, the more acidic it is. The larger the number gets, the less acidic it becomes, or it becomes, quote, more basic. And it may seem counterintuitive, that number looks like it's smaller than that one, but it's really not. 1.0 e to the negative 1 is just 0.1. And then 1 to the negative 2 is 0.01. So that's 0.001. That's 0.0001. And so on. So this would be the number of hydrogen ions to be found in an average amount of it. So all we're going to do is we're going to need to write a loop that will step through a series of concentrations and calculate the pHs. Now, sure does look like it would be easier if we used the pH to calculate the concentration rather than vice versa. Anyways, let's go down here and look. How do we generate this series of numbers? 1 times 10 to the negative 1 all the way out to 1 times 10 to the negative 14. We're just going to use a counter. And we're going to use the power of function. So we're going to write a counter that counts from 1 to 14 like this, and we will calculate our concentration here. So this already gives you a lot of the code. Here's the for loop. Here's the way we calculate a series of concentrations from that value to that value. And all we need to do is to pass those numbers in to this equation to get that number. Once you have those two numbers, you can print using printf to make it nicely formatted. And then it'd be really nice if you added a header of some kind and a series of dashes. And you can just play with that in order to get that to work. You don't necessarily even have to use printf in order to get the header. Might be nice, but you don't have to. Okay, so that's 5A. (5B) HTML is composed by and large of tags and modifiers for those tags. Let me just go, well, yeah, this page will probably do. You can right-click on something, do View Page Source, and you can see the HTML. Now, Google being what they are, this is extraordinarily complicated for what it looked like it was going to be. But there are, okay, fine. Let's find a better example. Really? What? Okay, let's look at that. View page source. Here we go. So a tag is something that starts with an angle brace. It has some kind of data, and then it ends in an angle brace. And then there are attributes. An attribute is something that looks like this. We're not going to use attributes in this one. But you could do image, style is equal to, I want this thing to have a width of 500 pixels. And I want the file name to be, you know, whatever.jpg. This is the tag. It's an image tag. All of this HTML will be used to specify an image on the screen. This is an attribute. It specifies how wide the image will be. And actually the style attribute can be used to put in a whole bunch of different code for formatting things. And then here is another attribute, the source, where we're supposed to load that file from. But at its most basic, the tags don't necessarily have to have attributes. They'll just be, you know, head, that's a tag. Title, that's a tag. There are things known as closing tags, which is the same word but ending in a slash, meaning that that's the end of the title. So here's the beginning of the title, here's the end of the title. Everything between that actually is the title. Here's the word head. That's the beginning of the header. Down here is the end of the header, because this one is this one is head, this one is slash head. Same for body. The body is everything between here and here. The header, H2 stands for make it a pretty big header, is everything between H2 and slash H2. Okay, so with that in mind, let's go back and look at the assignment. Don't know why it's giving me an error here. Incorrect package, yeah, whatever. Okay, so in HTML, a tag is a set of data contained between angle brackets, like this. Tag. That's the simplest one. Write a program that will prompt the user to enter a line of text. Your program will extract the text that's between the angle brackets and display it. So example, if the program was running, please enter a line of text and say the user typed in this. All good things must come to an end. Well, where's the tag? It's right there. So what is the text of the tag? Must come. So that's what it's supposed to print out. We will use substring to extract that from the string that they type in. We will use Indexof to find that and that. Just like we did in our example when we were looking for single quotes. So the tag found was must come. So here, enter another line of text. When in the course of human events. Well, there aren't any angles in this one, so no tag was found. We looked for an opening brace. It didn't find one at equal -1, so we didn't deal with it anymore. Okay, so hint, use next line because we want to get an entire line of text. Use Indexof to find the angle braces. If either one of those values are not found, if they equal to -1, you want to print an error message. Else you go ahead and use substring to get the tag out. And so, just as boilerplate, creating the scanner, creating, printing, enter a line of text, getting the text in, and then the rest of the program will go there. So do those make sense? We're pretty good on that? Okay. For a due date, since there are two sections of this, and we have a holiday coming up. We won't make this one due Sunday, but we'll make it due Tuesday of next week. I'm probably going to wind up pushing it back further than that. We'll see. Yeah, let's just make it Sunday of the week after. Don't put it off until then, of course, but that way you can enjoy your break without feeling guilty, without taking out your laptop while you're at Cancun. Okay, that's about where I want to stop. Let's make a Dropbox for what we've typed in, even though it was just examples. It was mostly examples of substring and Indexof, and then there were some printf statements as well. So we'll make this one called H. Substring, Indexof, and then printf. All right, it's there, so you can give me your Java file, please. Oh, I never assigned a due date for 4B. I guess I'll make it due the same day. Oh, no, that's an in class. That's not a take-home. I'm confusing myself. Let's go back. Yeah, that is homework, so we'll make it due October 30 as well. And again, don't wait. Really? All right, guys, Thursday is the break, so I won't see y'all Thursday. Instead, I'll see y'all next Tuesday, I hope.
Yeah, that's the plan.
If you get stuck on something, text me. Take a picture of your screen. It's the fastest way for me to respond. If you email me, it takes me longer to notice that you've sent email.